Hi, this is Huda Zenhom from Physics 2211, Section M, and this is Lab 1. The purpose of this lab is to observe and track the motion of an object at constant speed. I used an empty pill bottle on a smooth desk surface and recorded a video of the pill bottle rolling across the desk. I used the program tracker to track the motion in the video and created a computational model using GlowScript. I then compared the results of the observational and computational models using a spreadsheet and line graph. Finally, I connected the results to Newton's second law, which will be explained later on. So if we go into the program tracker and we run the video, each position is recorded for each timestamp, and the timestamps allotted were only the ones from constant speed as stated before. Here are all the positions over time tracked, and this graph shows that the positions are moving in the negative x direction because of the assigned axis, and we were only dealing with the x-axis because this is only moving the x direction, and it is negative because this section is the negative x-axis. So for the GlowScript program, we have to assign initial conditions. So the mass of the pill bottle is 0.02 kilograms, the position, which is only the x-coordinate because we're only dealing with the x-axis as stated before, and initial velocity and initial time of 0 seconds, and a delta t of 0.01, which is a small enough value so that the size of each timestamp, which creates a more accurate result. When we go into the GlowScript program, the overall purpose is to go through a while loop that goes through each timestamp until here, this time, because we want to calculate using a formula the velocity with an initial velocity plus this, which is acceleration, force over mass, times the change in time, again plugging that in to here to get position, and advancing the clock again. So we go through each timestamp to make the calculations. When we run this program, we also receive two graphs. One, which is the position over time graph, which is similar to the tracker one, in which it is decreasing in the negative x direction. And the velocity here, you can see it is constant. This is due to Newton's second law, which states that if we have a f-net of 0, which we do in this case, the acceleration will also be 0. And when the acceleration is 0, the velocity is constant. So if we plug in the data that we got from the computational and observed models, we get this graph. The results are similar, yet there are certain differences. And this is due to getting data from a video, which does not exactly correlate with the x-axis due to you can't guarantee that it is moving exactly in a straight line in situations such as that. And also the computational model uses an exact formula, unlike real life, which cannot be calculated in the same way. Okay, so if we flip the axes for the tracker data, we see that I flipped the axes so that now it is in the positive. This is the positive x direction, and it is increased. This would increase in the positive x direction. You can see here that now the positions are now increasing. Yet the velocity, which is the slope, which represents the slope, stays the same because, as stated before, velocity is constant when f-net is 0. Also, to conclude that f-net is 0, we have these three forces acting upon the object. We have a frictional force due to the desk's surface, we have a gravitational force pushing down on the object from the Earth, and a normal force which is pushing up onto the object because of the desk. The gravitational and normal force are equal yet opposite, creating the 0 value. It is important to understand the behavior of everyday objects to create new technology and observe and research occurrences within daily life. Thank you for watching and have a good day.